Good day, my viewers. Today I'm going to be solving differentiations through the various rules. There are some rules given in differentiation in which if you apply, some complex differentiations will be simple. Number one rule is the power rule. If you are given f of x to be equals to x raised to the power of n, the rule states that you multiply n by the coefficients of x, then minus n, which is the power from 1, which is n times 1. The coefficients of x is 1 times x raised to the power of n minus 1. I will have nx raised to the power of n minus 1. So for example, if I'm given f of x to be equals to 2x raised to the power of 2, I will have 2 times 2 times x raised to the power of 2 minus 1. So my result will be 4x raised to the power of 1, which is 4x. Then if I'm given f of x to be equals to 3 raised to the power of minus 2, I will have minus 2 times 3 times x raised to the power of minus 2 minus 1. So my result will be minus 6x raised to the power of minus 3. So the next one is the product rule. The product rule is f of x, which is the y, the x, is given as v, the u, all over the x, plus u, the v, all over the x. Okay, so we have the y, the x, to be equals to u, the v, all over the x, plus u, the v, all over the x. So now, if I'm given f of x to be equals to sine x cos x, sine x to be u, then cos x to be v. So I will multiply v times the differential value of u. So I will now have v, the u, all over the x, plus u, the v, all over the x. So I'll differentiate sine x, then multiply by cos x, then also I'll multiply sine x times the differential value of cos x, which I will have cos x. If you differentiate sine x, I will have cos x plus u, which is sine x. I'll differentiate v, which is cos x, is minus sine x. So I will have here cos x times cos x is cos x squared, plus minus plus is minus. So I will have sine x squared. So my result will be cos square x minus sine square x. So this is my result. So I apply the product rule to solve a question like this. Next one is the quotient rule. The quotient rule formula is the y all over the x is given as v, the u, all over the x, minus u, the v, all over the x. First, you write out the value of v, then all over v squared. This is the formula for quotient rule. I'll write out the value of v, then multiply it by the differential value of the u all over the x, then also multiply minus from the value of u, then multiply it by the differential value of v. So now, if I have something like a function f of x to be equals to sine x all over cos x, if I'm to differentiate this function sine x all over cos x, I'm going to use this formula. So if I'm to differentiate this, I will have that the y, the x is equals to, now this will be my u and this will be my v. the upside will be my u, the downside will be my v. So my u is this, my v is this. So here, first one is my v, and my v is cosine x, open bracket. I'll differentiate my u. So my u is sine x. So if I differentiate sine x, it will give me cos x minus my u is sine x, so I have sine x. Differentiate v, my v is cos x. So if I differentiate cos x, it will give me minus sine x all over v squared. And cos x is my v, so I have cos x square x. So if I multiply cos x times cos x to give me cos x square x, cos square x, then I have minus open bracket. If I multiply sine x times minus sine x, I'll have minus sine square x all over cos square x. Let me bring this upward. I have the y, the x is equals to cos x square x minus open bracket sine square x all over cos square x. So if I multiply minus 1 times minus 1 to give me a positive sign, which is what? Plus. So I have cos square x plus sine square x all over cos square. And from trig function, I have that sine square x plus cos square x is given as 1. So I'll now substitute 1 to where I see sine square x plus cos square x. So I'll now have the y, the x is given as 1 all over cos square x. So this will be my result.